Right now, somewhere in your kitchen, there's probably a stick of butter, a bottle of oil, or a piece of meat with the fat still on it. And when you cook with it, or bite into it, you don't think twice. It just tastes good, almost automatically. But that feeling, that pull toward fat, isn't a modern weakness. It isn't something fast food companies invented in a lab to sell you fries. It's older than agriculture, older than fire, older than the first stone tool ever shaped by hand. It goes back almost 2 million years, to a small group of early humans standing over the broken carcass of an animal, ignoring the meat entirely, and going straight for the bone. Because they weren't after the muscle, they were after what was hiding inside it. And understanding why takes us back further than almost anything else we eat today. In 1995, a theory was published that changed how scientists understood human evolution. It's called the expensive tissue hypothesis. The argument was this: the human brain is incredibly costly to run. It makes up about 2% of our body weight but burns roughly 20% of our daily energy. No other primate spends anywhere close to that much fuel on its brain, not even our closest relatives. So the question became, how did early humans afford it? Where did that extra energy come from? The answer researchers landed on was fat, specifically calorie-dense animal fat, the kind found in bone marrow and organ tissue, not lean muscle. The theory suggests that as early hominins started actively seeking out fat instead of just eating whatever meat they could find, their gut size actually shrank over generations, because fat is easier to digest than tough plant fiber, and digestion itself is expensive to run. That shrinking freed up energy that got redirected somewhere else entirely, into the brain. In other words, the fat wasn't just food. It may have been fuel for the very thing that made us human in the first place. This wasn't a slow accident either. It required deliberate behavior. Early humans had to know which bones held the most marrow, how to break them open without wasting effort, and when the payoff was even worth the risk of scavenging. That's not blind instinct. That's learned strategy, tested and passed down. So before we even get to the physical evidence buried in the ground, the science already tells us something important. This wasn't a minor dietary preference. If this theory holds, the craving for fat may be one of the reasons we now have brains capable of asking why we crave it at all. The earliest physical proof of this behavior comes from a site in East Africa called Olduvai Gorge, in what is now Tanzania. Around 1.8 million years ago, early humans were leaving behind piles of broken animal bones at a location archaeologists now call FLK Zinj. At first glance, it just looks like a mess. Scattered bones, some cracked, some splintered, buried in ancient sediment for nearly 2 million years. But when researchers looked closer at the pattern of damage, something didn't add up. If these early humans were only after meat, they would have stopped once the flesh was stripped away. Instead, the long bones, the femurs, the limb bones, were smashed open at the ends, using stone tools shaped specifically for percussion, cracked in a way that served no purpose except reaching the marrow inside. This wasn't leftover damage from other animals feeding on the carcass, and it wasn't accidental breakage from trampling or erosion either. The fracture patterns matched deliberate, controlled blows, the kind made by a hand holding a rock, not a predator's jaw. And here's the detail that changes the whole picture. Many of these animals weren't even freshly killed by the humans eating them. Evidence suggests a lot of this meat was scavenged, carcasses left behind by lions or other predators after they'd already eaten the best parts. Which means early humans weren't just hunting for meat. They were following other predators, waiting for leftovers, specifically for access to bones that still had marrow sealed inside them, fat that other animals couldn't reach without the right tool and the patience to use it. Think about what that means. Nearly 2 million years ago, before language, before fire was fully controlled, before anything we'd recognize as culture, humans had already figured out that fat was worth the extra work, worth trailing a lion for, worth carrying heavy stones just to crack a bone open. This wasn't opportunistic eating. It was targeted, deliberate, and repeated. And it's the oldest clear evidence we have that our ancestors weren't just eating to survive the day. They were eating, specifically, to fuel something bigger. Fast forward over 1 million years, and the evidence stops looking accidental and starts looking industrial. At a site in Germany called Neumark Nord, archaeologists uncovered something that didn't fit the usual picture of early humans as simple hunters. This site is around 125,000 years old, and it wasn't left by our direct ancestors. It was left by Neanderthals, a species we've spent decades underestimating. For a long time, Neanderthals were pictured as brute survivalists, killing what they could and eating it fast. But what turned up at Neumark Nord looked more like a production site than a kill site. Piles of bones, hundreds of them, smashed into small fragments, arranged near fire pits and shallow pools of water. This wasn't cracking a bone open for a quick snack between hunts. Researchers now believe this was a bone grease rendering operation, something closer to a workshop than a single meal. The bones were crushed, boiled in water over sustained heat, and the fat skimmed off the surface as it rose to the top. It's the same basic principle used to make stock or broth today, just without a pot. But doing this required planning, the right tools, reliable water access, and enough animal carcasses stockpiled in one place to make the process worth the labor. This wasn't opportunistic scavenging anymore. It was organized, repeated, and intentional. It meant a group of Neanderthals had to hunt or gather enough animals, transport the bones to one central location, and manage a process that took real time and coordination to pull off. All for fat, not meat, which they already had in abundance nearby. Fat, specifically, refined and extracted through a process closer to early food engineering than raw instinct. And this changes the timeline in a serious way. This wasn't modern humans figuring out fat mattered first. This was a separate branch of the human family tree, tens of thousands of years before agriculture, before permanent settlements, independently arriving at the exact same conclusion on their own, continents apart, with no contact between them, no shared culture to explain the overlap. If Newmark Nord shows fat being processed with real effort, the next question is bigger. Was this driving something beyond survival? A leading theory in human evolution argues yes, and it centers on what's often called the gray ceiling. Every land mammal seems to hit a natural limit on brain size relative to body size, based on how much energy its diet can supply. Most primates never come close to breaking that ceiling. Humans blew past it, and the timing lines up almost exactly with when our ancestors shifted toward fat-rich diets. The theory suggests that lean meat alone couldn't have funded this jump. Lean protein has a hard biological ceiling on how much the body can process before it becomes toxic, a limit sometimes called rabbit starvation, where eating too much lean meat and too little fat can actually cause malnutrition, even with a full stomach. Fat doesn't carry that same limit. It's dense, efficient, and far easier for the body to convert into usable, sustained energy. So during lean seasons, when plants were scarce and prey was thin, fat reserves inside bones and organs may have been the difference between a population surviving and a population collapsing entirely. Some researchers now argue this wasn't just about individual survival either. It may have shaped migration patterns, sending early humans following herds specifically toward fat-rich seasons, and it may have shaped social behavior too, since rendering fat at scale, like at Newmark Nord, required cooperation, shared labor, and food distributed across a group rather than eaten alone on the spot. In other words, the pursuit of fat may not have just fueled the brain directly. It may have helped build the social structures brains like ours needed to survive in the first place. Groups that shared fat, planned around it, and passed down the knowledge of where to find it may have simply outlasted the ones that didn't. If that's true, then the craving sitting in your kitchen right now isn't just about taste. It's the surviving edge of a strategy that once decided who made it through winter and who didn't. Okay, let's bring this back down to earth for a second. Imagine you're an early human at the end of a long winter. Food is scarce, you're exhausted, and someone hands you two options: a pile of lean, stringy meat, or a small handful of rendered fat. Which one are you reaching for? Yeah, exactly. Your body already knows the answer, even if your brains never thought about why. That instinct didn't disappear once civilization showed up. It just found new ways to express itself. By the time we reach ancient Egypt, fat wasn't just something people hunted for anymore. It became something people traded, stored, and used far beyond the dinner table. Animal fat was rendered into cooking oil, but it was also central to early medicine. Physicians mixed fat with herbs to create salves for wounds, skin conditions, and burns, because it helps seal in moisture and deliver other ingredients directly into the skin. It shows up constantly in surviving medical texts, prescribed for everything from infections to hair loss. Fat also played a major role in preservation. Long before refrigeration existed, meat packed and sealed in its own rendered fat could last for months without spoiling, a method that later spread across cultures worldwide, showing up again in European pantries centuries later, stored the exact same way. Then there's mummification, one of the most elaborate uses of fat in the ancient world. Specific animal and plant fats were used in embalming processes, chosen carefully for how well they preserved tissue and resisted decay over time. This wasn't guesswork. Embalmers had refined recipes, tested and passed down, because getting it wrong meant a body wouldn't survive the journey it was meant for. So by this point in history, fat wasn't simply food anymore. It was medicine sealing a wound. It was a preservative keeping meat edible through a season with no source of food. It was a material sacred enough to prepare a body for the afterlife itself. One substance, doing the work of a pharmacy, a pantry, and a temple, all at once. And it all traces back to the same instinct that sent a hungry hominin straight for a cracked bone nearly 2 million years earlier. The tools changed completely. The reason behind it never did. And it still shows up today, quietly, in every kitchen, every recipe, every craving nobody bothers to question. So here's the full picture. 2 million years ago, your ancestors were cracking open bones on an open savanna, chasing something hidden inside marrow they couldn't yet explain or even name. Over 1 million years later, a separate branch of humanity, the Neanderthals, were boiling those same bones down in shallow pools, rendering fat with a process that looked less like survival and more like early industry, organized and repeated. Somewhere in between, that pursuit may have quietly funded the very brain size that makes our species different from every other animal on this planet, breaking a ceiling nothing else in nature ever managed to break. It may have shaped migrations, sending groups following herds toward fat-rich seasons year after year. It may have shaped cooperation itself, groups sharing labor and food instead of eating alone, scattered and unprotected across open land. By the time real civilizations finally rose, fat had stopped being just a craving chased across a landscape. It was medicine, sealing wounds shut. It was preservation, keeping meat edible through long seasons with nothing fresh to eat. It was sacred enough to help prepare a body for its own afterlife, wrapped and stored with care. Every stage moved faster than the one before it, but the impulse driving it stayed exactly the same throughout, unchanged underneath all the new tools. Which brings us back to that small group of early humans standing over a broken carcass, ignoring the meat entirely, going straight for the bone underneath it. They didn't know why they wanted it so badly. They just knew it mattered enough to fight a lion for, enough to carry heavy stones for, enough to build an entire process around, generation after generation, long before anyone had a word for fat, or biology, or even themselves as a species with a story worth telling. So the next time you reach for butter melting on warm bread, or you don't stop the fork halfway through a fatty cut of steak, understand that you're not giving in to some modern indulgence built by marketers in a boardroom. You're finishing something that started on a forest floor, then a savanna, then a cave, then a boiling pool of water, long before your species had a name, a language, or a single word to explain why it felt so good. The craving never needed an explanation to survive this long. It just needed to keep working. We just learned, eventually, how to make it on purpose.